All right, this is the substitution steps for solving three variable, three equation systems. You only need to watch this if you preferred substitution over elimination, or if you tried elimination and you didn't like it. I will, however, say that elimination tends to be easier than substitution for these specific types of problems, because with substitution, you are going to end up with fractions most of the time, and sometimes a lot of fractions, which can make life difficult. Okay, so if you watch this video and then you decide I don't like this, you can try elimination instead, watching that video, but you have to pick one or the other. Like, those are your only two options. Okay, so pick whichever one ends up being easier, but do not watch this video unless you preferred substitution and you want to try it, or you already tried elimination and you weren't doing well with that. So we're going to start on page 5 here, down at the bottom, your substitution steps. So you're going to start like you did before with substitution. We're going to pick one of the equations to solve for one of the variables. There are no wrong choices, but there are usually some better options. So for example, you might want to look for a variable in one of your equations that does not have a coefficient. So for example, in this equation, y would be a good variable to solve for, because you just need to move 2x and negative 3z. You would subtract 2x and add 3z to the other side, just move them over there. If none of those are an option, at some point that's going to be the case where there are none with no coefficients, then I'm going to recommend you look for ones that have, because you're going to have to divide by those numbers. So like if I pick 2, or if I pick this negative 3, I'm eventually going to have to divide. It's going to possibly make fractions, but I would recommend, if possible, you try to pick one that's going to make fewer fractions. 4 can be divided by 2, so 2x is the second best choice. There is no wrong answer though, so if you don't notice those things or you don't care to take the time to figure that out, that's fine. It's just going to lead to more fractions in your problems. Okay, just be aware. You're going to complete the substitution process like you've already learned previously, using both of your other equations. You're going to substitute in. So if I solved this for y, I'm going to substitute whatever it equals into y in both of the other equations, so that those two equations will now both have x and z in them, but there should be no y's anymore. You're going to use those two equations to solve your system just like before. And you probably then, you can use substitution or you could use elimination, but you are probably the substitution route. So now you have two equations and two variables. You are going to solve that system using substitution, repeating basically what you did back up here, except now you have only two equations. Pick one, solve for a variable. Use that and substitute it into the other equation. That equation should now only have one variable. So solve for that variable. Get a number. Then take that answer and plug it back into the equation you solved for back up here to get your second variable. And then take that and plug it back into the one you solved for up here to get your third. So let's go through an example, because it makes so much more sense when you have an example to look at. So if here is your system, here are your three equations. Step number 1 is to pick one and solve for one variable. Does not matter, but I am going to point out that the second equation has x with no coefficient. So I'm going to recommend that you solve that one by itself. So step 1, I'm going to take x plus 3y minus 2z equals 19. I'm going to solve that to get x by itself. So you need to subtract 3y and you need to add 2z, so that it becomes x equals, and you can really write them in any order you want to. It doesn't matter. I'm just going to write them in the order they're in here. 19 minus 3y plus 2z. And I'm going to do my very best to help you know which one is a 2 and which one is a z. And I'm going to do that by making my z's with this line through them. Those are z's with a line through. Mathematically, that's how we distinguish between a 2 and a z. Now you have an equation that is solved for one of your variables. So now we're going to do that substitution step that you should know how to do if you preferred substitution. We need to do that in both of the other two equations. So this middle one was the one I used here. So I'm going to use the other two and substitute 19 minus 3y plus 2z in for x in the first equation and then in the second equation. So in the first equation, I'm going to take negative 3, take out x and substitute this in. 19 minus 3y plus 2z plus 2y plus 2z equals 15. All right, so I just took the first equation, substituted in for x, what I just found x equals. You cannot solve this equation because you have a z and a y, but you can simplify. So you're going to start with doing your distributing. Negative 3 times 19 is negative 57. Negative 3 times negative 3 becomes positive 9y. And negative 3 times 2 becomes negative 6z. And then just bring the rest down because there's no distributing. Plus 2y plus 2z equals 15. To make your life easier, you're going to want to simplify and combine like terms. So you've got a 9y and 2y, and you've got this negative 6z and this plus 2z. So 9 and 2 is going to give you 11y. Negative 6 plus 2 is going to give you minus 4z. And you do have your constants, but since they're on opposite sides, you're going to need to add 57. Oops, 57, not 75. That's a 57. I know it's hard to read because I tried to write 75. So you don't have to do that right now, but that's just a recommendation to get that to the other side. So 15 plus 75. Sorry, 15 plus 57. It's 57, not 75. It's 57 equals 72. So you have this equation now. We're going to pause. That is as simplified as that can go. Now we're going to take the third equation and do the same thing we did here. So third equation, we have 4. Take out x and plug in what we know. 19 minus 3y plus 2z. Minus 2y plus 3z equals 8. And repeat the process we did here. Distribute and combine like terms. We've got 4 times 19, which is 76. 4 times negative 3 is negative 12y. And 4 times 2 is 8z. And then bring down the rest that there's no distributing to do. So minus 2y plus 3z equals 8. Combine your y's, combine your z's, move your constant. So this positive 76 needs to get subtracted. Negative 12y minus 2y is negative 14y. 8z plus 3z is 11z. And what do we got? 8 minus 76 is negative 68. Okay. Now we are going to take those two. We have now 2 equations in 2 variables. We're going to solve that system just like you did in the last lesson. You may use elimination here if you want to, or you may use substitution, and it doesn't matter. You're allowed to start with substitution and then switch to elimination. It's perfectly fine. But since you got good at substitution, I'm going to recommend you stick with substitution. So I'm going to look at these 2 equations, and I'm going to notice. One moment, my lights went out. I don't know why that always happens with you guys. They don't want to turn back on. Oh, there we go. Sorry about that. Okay. You're going to notice that neither of these 2 have both of them have coefficients. Let's put it that way. And same here, both of them have coefficients. So there's not necessarily an easier one like there was in the beginning. So you could just pick one and just solve for one of the variables. You are going to have fractions. And I will tell you, you are going to have fractions no matter what. I will point out that if I solve this one for z, 72 is divisible by 4. So I will still have a fraction that you will see in a moment, but you're only going to have 1 instead of 2. So I'm going to solve this one for z. I'm going to do that by subtracting. Oh, let me rewrite it first. I'm going to need to move this 11y to the other side. So I'm going to subtract 11y. That gives me negative 4z equals 72 minus 11y. Now before I was done because x was by itself, but I'm not done here because you have this negative 4 in front. And you get rid of that by dividing everything by negative 4. So all 3 of your terms need to get divided by 4. This is where you're going to have those fractions. And this is where I said I'm going to have 1 and not 2. Obviously, your negative 4s over negative 4s cancel, leaving you with z equals 72 divided by negative 4 is negative 18. That is not a fraction. but you are going to have negative 11 divided by negative 4. That is going to be a fraction. The only thing you can simplify that is two negatives make a positive. So you can make this into positive 11 over 4 y, and you should write it as like separate number variable. So don't keep it like negative 11y over 4. I would write it as a fraction with a y attached. Okay, so now we're going to use substitution again, taking the equation we did not solve for and what we know z is. So negative 14y plus 11, but I'm going to replace z with negative 18 plus 11 over 4y equals negative 68. So I'm substituting right here. Instead of z, I'm replacing with what I just solved z equals. And repeat my process again. Distribute. So negative 14y, 11 times negative 18 would be negative 198. 11 times 11 over 4. The way fractions work, you multiply that number 11 times the numerator. So 11 times 11 is 121, and then over 4. You also can take your 11 and times it by a fraction, alpha y equals first one, 11 over 4, and it will tell you, and it would reduce it for you if it reduced, and it would divide it for you if it would divide. So it doesn't. So we do have plus 121 over 4y, and that's going to equal your negative 68. Now at this point, we do have only one variable, so we are going to solve for y. I'm going to combine my two like terms. I'm going to take negative 14 and add alpha y equals the first one, 121 over 4, and I get 65 over 4. So that's 65 over 4y minus 198 equals negative 68. You are going to add that 198. So that's 65 over 4y is going to be equal to 130. Now to solve this, my personal opinion of what's easiest is you're going to get rid of dividing by 4 by timesing by 4. So 65y is equal to 130 times 4 is 520. And then divide both sides by 65. So that y equals 8. And then we go back to the things we solved. So we're going to come back to this z equals and then back to this x equals, working our way backwards. We know y, so we're going to come back here. So z equals negative 18 plus 11 over 4 times 8. You can just type that in your calculator. Negative 18 plus alpha y equals the first one, 11 over 4 times 8. Z equals 4. And then we're going to go back up to this one. Oh, sorry, you can't see me. Back up to this one. So x equals 19 minus 3 times my y value, which is 8, plus 2 times my z value, which is 4. Type it in your calculator. 19 minus 3 times 8 plus 2 times 4, which is 3. So then your answer, x, y, z, put it in order 3, 8, 4. Not in order from smallest to largest, but in order alphabetically, x, y, z. To check it, which I know I'm going to run out of time, you're going to plug each one into each problem. So negative 3 times x, which was 3, plus 2 times your y, which was 8, plus 2 times z, which we found was 4. It is equal to 15. Yes, it is. Repeat your process. Plug in x, y, and z. Type it in. It should equal 19. Plug in x, y, z. Type it in your calculator. It should equal 8.